Good day, everyone. Today we are going to explore a framework that drives design excellence Six Sigma DMADV. This methodology is not just about quality, it is about strategy, innovation, and the relentless pursuit of perfection. To understand where we are going, we must look at the where we start. Six Sigma was introduced by Motorola in the 1980s to reduce defects and later popularized by General Electric in the 1990s, saving them billions. At its core, Six Sigma measures variation. A sigma represents the amount of variation in a process relative to what the customer wants. The goal is simple but ambitious 3.4 defects per million opportunities, which translates to being 99.9996% defect free. You might ask, is 99% accuracy enough in high value operations? The answer is no. 99% accuracy would mean thousands of failures every day. Six Sigma aims for near perfect standard where failure is extremely rare. Within Six Sigma, there are two methods. Okay, within Six Sigma, there are two methods. DMIC is used to improve existing process. DMADV, which stands of define, measure, analyze, design, and verify, is used to design new products or process correctly from the beginning. Phase is to clearly understand the problem, the project scope, and customer expectation. We begin by collecting the voice of the customer. This is done through surveys, interviews, and feedback. Customer needs are then translated into critical to quality characteristics, also known as CTQS. As we see, for example, if a customer wants fast delivery, this can convert it into a measurable requirement such as delivery within 24 hours. Okay, we also use a CPOC diagram to understand the overall process, including suppliers, inputs, process, outputs, and customers. Finally, all information is documented in a uh, project charter, which includes the project objective, scope, timeline, and team members. It ensures everyone is aligned before moving forward. The second phase is measure. In this phase, we quantify customer needs and define performance standards. A key tool used in the house of quality, which links customer requirements to technical design specifications. This helps prioritize design features that matter most to customers. Okay, let's we see benchmark. Benchmarking is also performed to compare our performance with competitors. This helps use set realistic and competitive targets. This is the graph of the showing the benchmarking. Okay, we also evaluate process capability using measures such as CP and CPK. These values tell us whether the process can consistently meet specifications. This pace ensures our design goals are measurable and achievable. In the analyze phase, we examine design options and identify potential risks. One important tool used in failure modes and effects analysis, or FMEA. This helps us identify possible failures before they occur. Each failure is rated based on severity, occurrence, and detection to calculate a risk priority number. High risk issues are addressed early to prevent future problems. We also use decision metrics to compare these alternatives based on cost, quality, and reliability. By the end of this phase, the best and safest design option is selected. The design phase is where the selected concept is developed into a detailed design. Engineering tools such as CAD, which means CAD models and simulation are used to test the design visually. This allows us to identify weakness and improve performance before physical production. Prototypes are the build to test the form, fit, and function of the design. This step ensures the design meets all critical to quality requirements before final production. Okay, the final phase is verify. In this phase, the design is tested under real operating conditions. Pilot testing is conducted to validate performance. Data is collected and compared with customer requirements. Statistical process controls charts are used to ensure the process is stable and consistent. Once the design meets all requirements, it is approved for full-scale implementation. In conclusion, Six Sigma DMADV provides a structured and systematic approach to designing high quality products and process. By following the steps define, measure, analyze, design, and verify, organizations can reduce cost, improve reliability, and increase customer satisfaction. DMADV ensures that quality is built into the design from the beginning, not corrected later. Thank you for your attention.